This problem is from the Merit Excellence Questions worksheet that's up on EWC. If you're watching this from somewhere else, then the equation is shown below. This is definitely the hardest question on the worksheet, and you need to combine quite a lot of different ideas to make it work. So the first thing that you'll notice when you look at this is that we've got a couple of things that are going to cause us a little bit of trouble. The best way to solve these is often to form a quadratic equation, but here we've got an x over 2 and here we've got an x. So we need to find a way to get those angles to be the same thing. The second thing that you might notice is we've got this 4 over here. Now, the best way to solve these kinds of problems is usually to form a quadratic. So something times something equals 0, and then we just find when is each of the factors equal to 0. That's not going to work with the 4. And you should make sure that you've done the other questions on this worksheet to get your brains in gear before you try this one. There are a couple of ways to go here to fix up having the angles being different. And I'm just going to do one of these in this video because that's going to be long enough. Okay, so when we see the sine squared term, that might make us think that we could somehow work with cos of 2 theta formulae, right? And that might work. I'm being pretty sloppy here, but you'll get the idea. So remember, we've got those 3 versions, right? And obviously I should have my thetas all everywhere in here. There they go. Right, now you can pursue that one. The one to work with would be this one here, linking with this. But I found a simpler way was instead to think about this term here. Now, I've got 5 sine of x. I somehow want to turn that x into an x on 2. So let's think about what sine of 2 theta is. Well, that's 2 sine theta cos theta. So, sine of x is equal to the sine of 2 times x over 2. So now we can force that into this pattern. So sine of x is equal to 2 sine x over 2 cos of x over 2. Right, so the next step of this problem is to substitute this in here. I'm going to do that on a new slide. Alright, so 10 sine squared of x minus 5, sine squared of x on 2 minus 5 sine x equals 4. 10 sine squared of x on 2 minus 5 times 2 sine x on 2 cos x on 2 equals 4. Now I'll just clean up what we've got here. You can see a factor starting to come of sine of x on 2, and we've got a cos of x on 2 in there as well. So looking ahead, I need to form a quadratic, but I've now got this cos of x on 2 popped in, and I've still got 4 sitting over here. So I don't want that constant because I've already got to deal with a sine and a cos. So instead I'm going to change that 4 into 4 lots of 1. I'm going to write that like this: cos squared of x on 2 plus sine squared of x on 2. Right, so I'm using my Pythagoras identity, which is extremely useful. Now I'm going to collect up like terms, and we've actually done all of the kind of creative bit of the problem now. So here we've got 10 sine squared of x on 2 minus 4 sine squared of x on 2 minus 10 sine x on 2 cos x on 2 minus 4 cos squared of x on 2, and now that's all equal to 0. Got a common factor in here of 2, so I'm going to knock that out, and I'm going to combine these together. So we've got 6 sine squared x on 2, so that's 3, dividing everything through by 2, 3 sine squared x on 2 minus 5 sine of x on 2 cos of x on 2 minus 2 cos squared of x on 2, and that equals 0. Now, if you don't like forming quadratics where you've got the sine and the cos floating around, I'll write it out again here. Just checking that I've got the right thing. So 3 sine squared x on 2. So while I'm mucking around with this, you can have a go at it. And we're going to need to hope that this is going to form a nice quadratic. But one way to do it, if you're having trouble looking at that and seeing what's going on, is just to use u and v. So we'll let u be the sine of x on 2 and let v be the cos. Lots of you won't need to do this, but some of you it might help. So we've got 3u squared minus 5uv minus 2v squared equals 0. So I'm going to do this by guess and check. Well, we must have 3u here and u here. And I need to end up with a minus 2v squared. So there's only a couple of ways that can work. I'm going to have to put a negative sign and a positive sign. And I'm going to have a 2. So let's try that. Minus 2 plus v. Well, that's not going to work, right? Because I'm going to have minus 2uv plus 3uv. So I'll just magically erase that. So let's see what will work instead. Well, if we do u here, minus 2v here, that's going to generate minus 6, and then I'm going to add one of them back. So let's check that before we go any further. Does it definitely work? Yep, 3u squared here, that should be a v, not a plus 1, plus uv, minus 6uv, so that works, minus 2uv squared. Now we put it all back in terms of the trig ratios, and we get this. So either, what do we got? 3 sine of x over 2 plus cos of x over 2 equals 0, or sine x over 2 minus 2 cos x over 2 equals 0. Now we need to solve those two equations. I'll take a new slide to do that, and we'll do general solutions for each. Okay, so the first one, 3 sine of x over 2 equals negative cos of x over 2. Well, we've got dividing through by cos, tan of x over 2 is equal to negative 1/3. I've done that a little bit faster than I have in some of the other videos. I'm figuring if you've made it to this point, you know what I'm doing with that. Okay, and then in this next one, I've got sine of x over 2 is equal to 2 cos x over 2. So again, dividing through by cos, I get tan of x on 2 is equal to 2. Right, so general solutions on those, we've got alpha is the angle whose tan is negative 1/3 here, and over here I've got that. Not particularly nice numbers, so just remember, hold them in your calculator, don't round till the end. And we get, now substituting in here, x over 2 is equal to n pi minus 0.3217, and here I get x over 2. So the angle whose tan is 2 is 1.1071. So here we get x over 2 is n pi plus that. Multiplying everything through by 2, we get x equals 2n pi minus 0.644. And here we get x is equal to 2n pi plus 2.21. Okay, but obviously all the hard work is done in the first part where you're working out what identities to use. Thanks for watching, and send me an email if there are any others that you need help with from that worksheet.